We started yesterday the mapreduce. I will show you today how to run the cluster. It's the same mapreduce program. We will see that how to run the Hadoop cluster. Hadoop service, right? How to use to run the mapreduce. Has anyone any question in the mapreduce program first of all? The code, mapreduce program code. Everybody understood what is the architecture of the mapreduce? What is functionality? How mapreduce works? What is a map? What is a reduce function? What is a shuffle and sort? Is clear? Okay. So what map does? Can anyone tell me what map function does? Hmm? What map function does? In the map reduce, we have map function, shuffle and sort for space, shuffle, sort, and we have reduce space. So what this map does? What is the purpose? Mhm. Yeah, generally what is does, right?
It might run two parallel commands at the same time.
Parallel processing.
Yeah,
Yeah, distributing the data, right? Map is basically distributing the data into the LLM machine, mapper machine, and giving each word is a one count, right? It's splitting the data and giving each word as a one count. That's a map. We get a
Arvind, uh, here I just want to ask something. So, how does it assign 111 you are saying, right? Say, suppose, hello, how are you? So, how does it assign numbers to each word? I didn't get that exactly how functionality works there.
it is not assigning one. Actually, it is giving each word is one count. Okay. So let me come to yesterday. Mm. So if I have some text file, I say I have a file hello.txt. Mhm. And hello.txt file have some set of words are there, lines are there. Okay. So when this file is so our MapReduce program is start from the driver, right? The driver is calling the mapper class, right? The mapper class has a map function, right? And reducer class have reduce function. So when this map function is called, so what map function is doing? It is distributing this like basically when this class is having this map function. So it is accepting the each line of the text, right? It is given to the one word map. So just assuming it like this map function is taken by so every line is starting with some offset position. So I say this starting position is a 0. So here is a key value pair. So 0 is the offset as a key, and value is a text of line, right? This text of line is a value. Same thing is here. Here is the offset is suppose 15. Okay. I'm saying some position is there depending on the character. So it will take it automatically because this offset we are not giving. Okay. We are providing this hello.txt file. But for this hello.txt file, so when mapreduce function, right, takes a parameter, so it takes as a key value pair. So first, this one machine is taking this one, and second mapper machine is taking this second line. So here, what map function does? The map function is first splitting. You have seen yesterday code, right? There in the map function, we are using the space as a delimited character and splitting the line into the words, and we get the array of string words. Okay, then each word I'm taking it and giving one count. So it is giving each word one count. Hello is one, how is one, r is one, and u is one. Okay. Same thing will happen here also. Okay. So same thing will happen on the another mapper machine. Okay. And when the second process is this output is sent, this output is on this one machine, this output is on one machine, right? But when the shuffle and sort is called, when the internally, because this is not in our control, shuffle and sort, the shuffle and sort phase basically is taking your this input and doing the shuffling for the same key together and make it sorting. After that, sorting. So after sorting, if you see what will be the sequence will come r comma 1, because 2 time is there. Second one is in the sorting order h key hello will come. So that is also 1, 1. Next one is how is there 1, 1, and r is and u is 1, 1. So this is written by this is also key value pair. The key is your string is a key, text is a key, and value is a list of values is your list of values are your value. Okay. Once this shuffle and sort output is given to the reducer, the last phase is the reduce phase. The reducer is basically there is a class reducer class. The reducer class has reduce function, and this reduce function is basically same key is like the same key has this list of values. It will be doing just aggregation, like count. It is doing count. So r comma 2, hello comma 2, okay, and how comma 2, and u comma 2. So like this, you will get the final output from the reducer. So this output will be saved in a one file. So you have given input as a hello.txt like this file, and you got the output like this value. So this is the MapReduce architecture. So you can explain anyone your this MapReduce. Is it clear now?
Yeah,
Okay.
thank you. Yeah,
So coding wise, when you do coding, you have 3 classes you have to remember. Okay, I'm not saying you should remember the complete code. Just high level code if you speak, and you can tell anyone to driver class. That is starting your job object, and this job object you are setting in mapper class name, because you have to invoke from driver mapper class. So set mapper class, you have to set mapper class name, set reducer class, you will be setting reducer class. Okay, and then job dot like start, you will start job. So your job will call first mapper class map function. Okay, and once map function is called, then reduce function will call, and then finally we'll come back to the driver and job dot terminate. Okay, so there is a like you have seen that job dot, if you get return value is of 0 is for successfully executed. Okay, successfully completed, your job is completed successfully without any error. If it is 1, 1 means completed with error. With error. So your error is there. So your job is not successfully completed. Okay. So either 0 or 1, based on that, we can come to know our job is successfully completed or not complete. So we can run the program in the 2 ways. We can run the program in the IntelliJ. We can run the program in IntelliJ IDEA. There we can create a Java project, and this Java project has all those classes. I have given the code. So I have a driver class, one is a mapper class, and one reducer class. Then we create a jar of this project. Okay, if I want to run directly, so run configuration I go. So in edit configuration I go and I create a edit configuration. And edit configuration I create a Java application. Create Java application. So in IntelliJ we can create a Java application and run the mapreduce code. And the second way is I can create a jar here, create jar of Java project, mapreduce Java project, mapreduce Java project. So basically, when you create a jar, it is a classes. The jar is nothing but is a collection of classes. So you know the difference between the jar, var, er, okay, collection of classes. So generally, jar means just collection of classes, collection of the classes. The jar can be for any application, the Java application, we can create a jar. But var is web application, right? When a internet application I'm creating, like where is some front end UI is there, Angular, React, okay, or HTML, jQuery, right? So when we are using any internet application, web application, internet web application, then we create a var file. But this var file we have to deploy in some application server. Okay, so like Tomcat application server, if you heard about the name application server. And ER is a bundle of var and jar. Var and jar. So most of the time, right, when we have my application, it's a collection of both. So if I say my application is a web application, but I have some other jar application also, in that case, I will go for ER type. Okay. But here is a simple MapReduce program. There is no front end, back end is there, front end is there. Okay. So just only jar is, we are creating a jar. So whatever our driver class, mapper class, reducer class, so all 3 classes, 3 Java file will be converting into the classes. And I told you this classes can be done anywhere because it is byte code, right? It is executable code. So the Java Java classes once converted into the classes, because the Java source files are converted into byte code classes, right? So this can be run anywhere JVM, okay, Java virtual machine. So we can execute these classes. Okay, so we will use the Hadoop jar command. So when we are going to run on our Hadoop cluster, so we should run with the Hadoop jar command. So Hadoop jar, whatever jar you created, jar name, and we will give our main class name, okay, with package com.test.my driver class, okay, and then we can provide input path and output path. Okay. So yesterday I run the program in editor, the same MapReduce store. If I want to run in cluster my Hadoop, so I have to use this command, Hadoop jar command. Okay, I will show you how to do that. So generally we do editor one for testing purpose, okay? Because we cannot see actual cluster configuration, right? Because when we are running locally in my editor, so it is just using the jar and running the program. Okay, but actual cluster resources like my cluster is one node cluster or two node cluster, or how much memory or CPUs in my cluster, it cannot be utilized. So for testing purpose, we can run in editor, but when you want to test in the actual cluster, we have to use this Hadoop jar command. Okay? So for Hadoop jar command, we have to we have to create a jar. So same project. Yesterday I run in the IntelliJ. I will create a jar of that project. So I open my IntelliJ. Have you guys installed the IntelliJ? Right, I told like download the Ubuntu version, and then you can download Ubuntu version, and then you can extract. Then you can like that. You can run this file idea.sh. Start your. This will give you the practice of how to run a MapReduce application, and even like later if you are going to create any Java project, a small application, right, utility application, so you can understand how to create a Maven based Java project. Okay. So and how to create a jar of the Maven project, because we have to see the similar kind of thing in UDF, high UDF. So high UDF is a Java, right, code we write. Okay. So Hive is a SQL tool, right? I already told, right? A data warehouse tool, SQL query tool. So when I'm going to use inbuilt function, right? Upper function, lower function, right? So these are the utility functions, like SQL functions. But suppose I want to write my custom logic in my function, I want to execute, then I will write Java. Okay. UDF can be written in Python as well as Java, but you should know, but you can write your custom code. Okay. So we will create a sub Java class, and then we will use that Java class in our UDF. So here we are using mapreduce. Okay, so here yesterday I run the mapreduce program. So I want to create a jar. So I will go to the edit configuration, and here is a Maven. Okay, so I have to create now this time Maven type application, not the application. So yesterday I created application type. Now we have to create a Maven type because we have to create a jar. So when we want to create a jar, so we have to give the command, clean install command. So Maven is a build tool that is building your classes. They are building the source file into the classes. So clean install is a command. So clean is basically cleaning the dependencies, like some existing dependency is already attached. And if you have removed those dependencies, so it will be removed. And install is basically creating a jar. Okay. So I define this run command clean install, and I will be giving a directory, this entire application jar I want to create. Okay. So there are many main classes are there, right? So many main classes, main function are there, right? So I will be, when I will use the jar, that time I will tell which main class I want to use. Because in my MapReduce program, I've already specified, if you see word count job, this is my driver class. So here I have already mentioned my jar by class name is word count job. Okay, so I have to use this class as a driver class. So I can create a jar of this project. So I have to run the Maven build. So if you see here, this map reduce clean install command. So once this execute is activated, once this execute button activated, I can uh, I can create a job. Okay, so now I can execute button. So I click on this. So it will create a jar file in the target folder. So this target folder, so already that this is a previous jar. Once this build is completed, once this build is completed, so I will see this target having the updated my mapreduce jar. I my this build is completed. Now I will copy this jar file. So some data file I copy here. I have to start my Hadoop services. Okay, because without running Hadoop services, because when you are running in IntelliJ, you don't need to start your Hadoop services. Even you can stop it from the problem. But when you want to run on the cluster, so you have to start your. You have to upload a input file on the Hadoop file system because I want to process the data. So I take it same input file. Yesterday I took this XYZ. Remember, right? This XYZ. It has all countries, words are there, right? So I take this file and this file I will I will put it in the Hadoop. So your data should be on Hadoop. Your jar will be fine here. Okay. But your data input and output will be on Hadoop. When you are running the job on the Hadoop cluster, MapReduce job in the cluster, so your input and output will be in Hadoop file system. Okay. I open a terminal here. So I will write my command Hadoop jar. Okay, first I create a directory so that I can copy this input file XY. So I just check my services running. Input file plus minimum. Directory I created so that I can find my data. Okay, my input and output I can put it here. Okay. So Hadoop fs minus port command. So local I have a XYZ file and I want to copy this. I created this in not, it is not on the root, okay? This is not on the root. Okay? It is in the base directory I created. I copied the input file, okay? And if I see Hadoop files use flash. Okay, so I created a directory and I'm putting the file. Let's see. Let's increase the file. So I'm getting the 1024 correct classified. So file is uploaded. So my jar is here. If I check here, here is my jar. So what is my command? Hadoop jar name. Okay. Then I have to give my driver class. So what is my package of the driver class? My driver class is a word form job. So his name is org.example. org.example. Dot. There is no class, something will not come because when we execute any class, we don't give the class. Okay. So org example dot my driver class. And now we have to give the input path and output path. So what is my input path? I created a mapred test 1, 2, 3, test 1, 2, 3 slash xyz. This is my input file, and output file I create in the same folder test 1, 2, 3, and I gave some new folder because mapreduce job needs some new folder, so I'm giving the output. So output is not there, so it will automatically create it. So now I submitted my job, mapreduce job. So you seen that when I was running with IntelliJ, I was not able to see this log. Actually, there is a log is not appearing, but backend it is doing this kind of log. But here, this is running on the cluster. So similar type of logs will be in the IntelliJ one. So here the job is completed. Right? This is, if I see here, the number of byte read this much, number of byte written this much. Okay. So it is talking about how many records we got it. So this map record 36,626 record by read by the map. Okay. And how many map output record? So the key value pair, I told you, right? The map output is a key value pair, right? Word, comma, one, word, comma, one. So it is, can you check here how many? So this is 36,626, but this is total word, right? And this is 164,814. And this is the output in the byte. Okay. If you see the reducer part, reduce. So reduce in input record is 16,164,817. This is the same number, whatever map is given, right? And once the reducer given output, it is only 9 record. 9 record means total number of lines are 9. Okay. Because each country is a one word in each line and their count is there. Okay. So let's see the output. You will understand more here. So when I check the output, produce fs minus get command, and I will get that test output slash part R. So our MapReduce output file name is part R. If you seen here when I showed yesterday output, okay. So if any output you see here, it is always creating the output part hyphen R 0000, right? The same naming convention is in the Hadoop. Okay. So here, and I want to check my file. So 5 kilos. So it should give me the output of the 9 record. So these are the 9 record. These are the countries, right? So these are countries and they are got from this country. So it's the same output. There is no difference in the output. Okay. But cluster output, cluster job will be faster than the local, right? In the IntelliJ. Mhm. So here, this is the MapReduce job we run on the cluster. Okay. So generally, when you want to test your code, you can test your code here local in the IntelliJ. Okay. But when you want to test in the Hadoop file system, then you have to create a jar of this project and run the driver class inside it. This is the Hadoop jar command. This command you have to so this is just a sample I do. This is the actual command, right? So you have to give the actual jar name, right? And you have to give the driver class, and you have to give the input path and output path. Because these are the two parameters are given to your MapReduce job. If you see your driver class, so you are passing the ARGS parameter. So this argument parameter is like here you are receiving these two parameters, ARGS0 and ARGS1. The ARGS parameter is your input path and ARGS1 is your output. If I run my job again, will it give me the error or not? Like your directory already exists, that error will come or not if I run this job again?
No.
Because I set it this code will handle that. If I comment this code and create a jar again and I run my code, I will get error. Output directory already exists. But if I run multiple times again and again, I run this job, same output I'm not changing. This output directory I'm not. So another way is you can change your output directory name. So it will create another new output directory. But for same output directory, so you have to write this delete, right? This one you are saying to delete your output directory path and create again same output directory. So here it will not give any error. It will same directory it is creating again output. Okay. So output will remain same every time it will same. If you see that file, if you check that file, ls command, so you will find your directory is created again. If you see, so this time you can see 9:07. It's just a recent time, right? So this is a recent time. So it is delete and created. Okay, so there are many other MapReduce program like we have a concept of combiner. So just I quickly show you demo. Okay, so at least you can understand what are the concepts are there in MapReduce. So what is combiner? So sometime what happens? I give you the scenario. Generally, what happens and why we need combiner and partitioner. So two concepts are there: combiner and partition. Okay. So one scenario you see, I'm having so many repeated word is there, right? If I say India is a one country, Japan is a one country, so it is repeating thousands of times or millions of times. It could be a case, right? So generally, what happens in your MapReduce program, every word you are giving one, right? So even though in the same mapper machine, if I take an example here, in this one, suppose this hello is more number of times is there. So if I look at ideally, this is same hello key, right? But if I'm not using the combiner, so what will happen if I'm normally running a MapReduce program? So this normal MapReduce program, what it will do, it will add same hello 4 times. Hello, comma 1, hello, comma 1, hello, comma 1. Because my logic is saying give each word is a 1 count. Okay. But I want to improve the performance, right? I say if in the same machine, instead of hello, comma 1, 4 times or 5 times, okay, can I make it hello, comma 5? Okay, because in this machine itself, I know hello is how many times hello is there. I want those many number of counts. So if I say this mapper should return hello, comma 5 and remaining whatever count is there. So I'm giving, okay, R is 1, U is 1, right? How is 1. But whatever word is repeated, I want to combine it, okay? So, but if you look at, this is also aggregation, right? If this hello, comma 1, this hello, comma 1, if I'm going to do, this is same aggregation you are doing in the reducer. So if I say, whatever work you are doing in the reducer, same work if you do in the mapper, if you do the same work in the mapper, so your issue will be resolved, right? So MapReduce has suggested the combiner. So combiner works mapper side, and you don't need to write any code for this. You don't need to write any class for this. So works mapper side and take same class of your reducer. Okay. So you can use the same reducer class because reducer is doing the logic of aggregation for the same key. Whether these keys are coming from the different mapper machine or in the same mapper machine, it doesn't matter. Okay. So if I say, if I want to, so if I say if combiner is like works as mapper side and it takes the same class of your reducer. So in my mapreduce program, here, if I job.set combiner class, if I set it reducer class, so my work will be solved. So my reducer class, the reducer is there, but that is for different mappers aggregation. But it's the same mapper machine aggregation, we can use combiner, and combiner also need a some class. So one way is you write another new class, combiner class, and write the same code of reducer. Or another option is don't create a new class as a combiner. Whatever your reducer is there, you just pass it here also. So if you pass it here, what combiner will do? So combiner will be acting at the mapper side as a mini reducer. So combiner is acting as a mini reducer. Combiner is it is acting as mini reducer. Why it is called mini reducer? Because it is not exactly reducer what is doing. It is mini reducer. It is partially doing the reducer work at mapper side. Okay. So that is the reason combiner we can configure by providing the reducer class. It is acting as a mini reducer. So code wise, just only one line you have to add. Just enable this line. Okay. If I say if my reducer class, if I'm not enable this parameter, my combiner will not be coming in picture. So what mapreduce program says, in the job object, if you set the combiner class in the driver, so your combiner will come in picture. So where the combiner will come in picture? Here in the flow, before shuffle and sort, your combiner will come in picture. So here combiner will be, if I say here, combiner will come and it will give this output. It will return this one. Okay. So if you see, this particular line is converted into this, and this line will be same, right? Because there is no repeated, right? No repeated word. So if I say there is no repeated, so it will remain same. So this will go to the shuffle and sort. And when the shuffle and sort, now hello is coming 5,1. Now while applying the combiner, this hello will become now 5,1 because 5 is coming from this mapper machine and this 1 is coming from this mapper machine. And your final reducer output will be also changed. It will become like 6, right? Okay. So whatever calculation is there. Okay. So this way your combiner works. Okay. Second thing is partitioner. Partitioner is like you are getting only one output file. You are getting one output file, right? And one output file name is what? part-r-000, right? This is your one output file. Can you see this output has all the words? I mean, right now, if you have seen the output, you are able to see output of only 7 words are there. But suppose I say I have 100,000 words are there. Okay, different words are there. And I will ask you find a letter word, particular a letter word you find. So you have to search entire file. So to find a particular word, right? Particular letter, starting word in reducer output file. So reducer output file, you need to search entire file, right? Okay. Even though sorting order is there, but you have to search entire file. But if I make it your work easy, I say I will use some partitioner class. My partitioner class will be there. And this partitioner class will distribute my words in 26 files because I know if A to G letter, 26 letters. Okay, so maximum numbers of files I can create 26 file. Okay, but maybe some files they don't have the word. Okay, depending, right? But I'm taking the use case, right? I'm taking a use case. Okay, or I say the use case, right? I want a letter word in one file and rest of the word in a second file. So I will create a one partitioner class, and this partitioner class has one get partition function, and this get partition function will distribute 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 output into number of reducer files. So here the one change will be coming. Your output is distributed in a single file, and it is using the hash partitioner default. So hash partitioner is a default partitioner. So when you are getting a one output file like this, because of hash partitioner. But what I'm saying, this is custom partitioner. So we are writing a partition class, right? We are writing a partition class. We'll use custom partition logic. Custom partition logic. Okay. This is a scenario I given, like we can, based on the letter, right? Starting letter, I can check for the key, and then I can distribute the file. But I can say any scenario is there. Suppose I have a data of male, female. So I have a data in my file like male, gender is there. Okay. So gender basis, I want to distribute the file. So I know gender, if I find male, so I will check. So I will create a one output file. So one output file. Okay. And when the gender female, so I will create a second output file. So it depends what criteria is there for distribution of your output. You can write the logic in your partitioner class. So let me show you partitioner class. So you can see how can you implement partitioner and combine. Okay. So for partitioner class, carefully to understand what are the configuration is needed for partitioner class. So here, first of all, in the driver class, we have to enable this parameter job.set partitioner class, and I have created a one separate custom partitioner class. And one more thing I have to give, how many number of partitions you want to distribute. So I'm saying num reduce task means 3 output file. Okay. So if you are saying 3 here, so you have to write a logic in such a way it should create max 3 files, because I'm giving a number of reduced tasks 3. So it will create only 3 output file. Okay. How to write a logic? So first thing is we have to enable these properties. We have to add the properties. Otherwise, if you comment this one and your code is there, the partitioner class is there, in the application, your partitioner class is there, right? This class, but you have disabled this, then it will not work out, right? You know, this is a commented. So you have to enable the code. You have to enable the Java code, and this partitioner class will be executed. So how the partitioner class code is written here? It is very simple way it is written. So you know, right? Any class, right? Mapper class, reducer class, it's taking the input parameter. So this is the 2 parameter type, like key is the text and int writable. So what type of values we are getting, and partitioner also work at the mapper side. Basically, it apply mapper side, but final output you will get the reducer side. So when I say, so your partitioner here, suppose you are applying both, right? Combiner will apply first, and then partitioner will come and it will apply logic on each key like here, and define which output file it will go, in reducer, okay? In reducer phase. Okay. Because actual reducer phase is only distributing the data, right? When the reducer phase is writing the data into the output file. Okay. So this will be decided, but it will be acting at the mapper side only after the combiner, if combiner is there. So here I'm writing a logic here. Get partition function is taking a text as a key and int writable a value. Okay. So, and number of reduced tasks I'm taking. So first I'm checking number of reduced task condition, what the number of reduced task is coming. So if it is coming 0, like suppose number of reduced tasks 0 I'm giving, I don't want the any partition. So that is a default as a hash partition. So this particular code can work for both. It can work for the only one reducer file or multiple output file. So even I'm using partitioner, but if I pass my num reduce task 0 here, so it will not, partitioner is using, custom partitioner is using, but the custom partitioner is also creating a single output file, like same without partitioner also. Okay. If I'm not using partitioner, then it will be using only one output file. Okay. That is a default logic. Okay. But even I'm using a partitioner and I'm passing a 0. So I'm checking a condition here. If it is a 0, so return 0. So only one output file it will return. But suppose my num reduce task is not 0. So I will be checking if my key is starting letter is A. So return 0. It will go to one file. Okay. So 0 means here is, this is a hash value is returning, right? 0 is for 1 and 1 is for the second file and third is third file. So you know the naming convention is taken by the mapreduce because we cannot define those file names. Okay. So return 0 means part -r-00 will be taken. When I'm saying if key start with the G letter, so it will do one, like the part -r-110001, or if other remaining words, so either is a or G or rest of the word, okay, which is not starting with A and G, will go to the third file. Okay. So this is my logic. Okay. Now I will create again jar. Same process I will do. Okay. I will create a jar. I will run the job on my mapreduce input folder. Okay. Input file. So my jar is created. Now I will overwrite my jar because this jar which I was using here, this jar, right? This jar is my old jar. So I replace it. Okay. So now this is my new jar, or we can check with the LL commands. So we can check here. It is 924. It is updated. Okay. I keep it everything same. Just I want to run my mapreduce job for the same data. Okay. But here I will, even you can use the same output folder, but I want to create a different output folder because here we'll be creating a P files. Okay. So I will be running my mapreduce job. Even in the editor also you can run. If you want to run in editor, the same is partitioner code. So yesterday we created a one edit configuration. We created a one Java application type. So we created a application type, go here application type. So okay, so I'm giving some XYZ. I'm giving a test1 folder XYZ file, and this test1 folder I will create, or even I can keep it same output folder because my file will be. So this one, so I'm running now the code with what? partitioner and combiner. Both are there. Okay. Let's see. This is done. Can you see this time the reducer is changed? This is the last time when we checked. Can you see here reduce is 0 and immediately it came 100? So it means it's a one single file, right? 0 to 100. But this time if you see, your reducer is also varying. Once your map is completed, then reduce is starting from the 33, then 67, and then 100, right? 3 part, correct? Because I giving a 3 num reduce task, right? So your reducer is divided into the 3 tasks, right? One is basically writing a one output file, second one is writing second output file, and third one is writing third output file. Okay. So let's see what is the output one I given. So this output one folder, I verify my output. So I will see first Hadoop fs minus ls command to check how many files. Can you see here 3 files are created? So if you see one file is showing 0 file, no data, right? So in this file, it is an empty file. Why it is empty? Because when I see in my logic, if any word is not starting with a letter, okay, so definitely it will be. So if I see my last output, right, I printed here. Here, can you see any word is starting with a letter? No, right? So that is the reason that file is empty. And one is a Germany, right? This is a G letter word. And rest of the word will go to the third file. Okay. So let's see the second file output. The second file is this one, part R001. I do the cat command. You'll see only Germany will be there. Can you see Germany only? So this is because of the partitioning. So combiner effect you will not be able to see unless your data is very, very large, okay, and repeated data. So if you are having this in this particular file, the repeated data is more. So you will see the performance time will be better, right? The normal without combiner. Okay. So combiner is improving the performance. And if you see the third file, 001, 002. So here rest of the countries, key value pair is there, right? So key value pair. So this is a partitioner. So partitioner is making it easy for you to create output file to find your word count, right? So it is not performance, right? So combiner is for performance. It is improving the performance, but partitioner is basically making ease of your output file to search, or you can easily get out of the data from the output. So this is the way like a partitioner and combiner logic works. Is it clear this one? So in mapreduce join is also there. So that is a one more concept. Okay. So there are the two types of join is there, map side join and reduce side join. Okay. So I will just tell the concept so that you can get the idea. Okay. Map side join, reduce side join. Tomorrow I will show to you. Okay. And I will start the high. Okay. So just to do practice this, if you are able to run the program and understand concept and you can explain the concept, that is sufficient for in MapReduce. Okay. You don't need to write specific complete Java code for writing. Okay. So understand a simple MapReduce word count architecture, like what is the MapReduce word, MapReduce map and reduce architecture. Okay, mapreduce architecture, and what is the combiner, partitioner, and the next concept will be map side join and reduce side join. So two joins are there. So map side join is basically join is happening at the mapper side, and when the join is happening reducer side, that is called the map side reduce side join. Okay, so You have seen the join happen in the SQL, but here we are joining the two files. Like one file is a emp.txt file and one file is a department.txt. So when I say emp and department.txt file, and like emp.txt file has emp ID, emp name, and department ID. And department.txt file, I have a data like dpt ID, and dpt name. So I want my output something like this: emp ID, emp name, and dpt ID and dpt name. So this kind of output can come by map side join because there is no need of reducer. Have you seen the reducer is doing the some calculations, some aggregations things it's doing? Okay. So it's combining the data, right? That is basically reduce side join. So here is simple, like I'm reading a two file and just I'm combining the columns and creating a one single output, one file I'm creating with like fields from the another file, right? It's a join basically. So here department ID is common column. Based on that, I'm getting. So this is the map section. Okay. So just go through it. You will understand, right? What is a reduce side join? What is a map side join? Okay. Anyone has any question? Okay. Go through this. Okay. Tomorrow I will finish this mapreduce and start the Hive. Okay. And has anyone installed Hive? Anybody got the issue? Anybody installed Hive?
Arvind, I tried installing, but I was getting some issues. I'm trying to resolve this.
What issue is coming?
Let me show you.
Okay. So let me check quickly. So okay. Okay.
Sorry.
So you are
I
getting right this one. Okay. So you open your and bash RC.
okay.
And
I
actually,
I put those two lines of code.
yeah, two line, but actually there is a issue. Actually, you have not seen in my document. You followed on
Oh,
the right. So website,
yeah.
see, whenever you are writing the path, it should not having any single character space. Okay.
Oh,
If
okay.
space is there, then it will not be recognized. Control X.
Mhm.
And whenever you are saving the file in the nano, okay, because somebody is not able to save. So I'm telling you, see, VI editor and nano editor both are different. VI editor we use :WQ, right, and we can save. But this is a nano editor, so you use Control X, then Shift Y, and enter. After that, you have to do source command, BASHRC. Okay. Now see there is no error. Okay. So if you are following this, okay, so your you have initialized the schema that um,
Yeah,
Derby. Okay.
yeah.
Okay. So still you will get one more issue if you have done uh, at least one Java temp IO TIR, some issue will come. Okay, will come.
Oh,
Okay.
I think it's working.
Then let me check create database. So you can check by creating database because if it is able to create a database successfully, see if there is an error. Okay.
Oh,
So
okay.
you have I'm going to ask you, did you conference or how? So when you done this, have you created these directories, everything? This one?
Not yet.
Yeah, so see, it is all steps, right? Because we cannot jump to Hive directly because this one is the last command, okay? Once everything is done. So you have to run
Okay.
warehouse directory because if this is not there, so it will not do. So you have to, your loop is running, and you run this command. So it will create a warehouse directory. Okay.
Okay.
Because this
Okay.
warehouse directory is a internal directory for storing your tables data. Okay, internal table. And then we have to give the permission also. So we are giving a group permission as a write permission. Okay. So
Okay.
this G plus W command. And another directory we have to create temp directory. The two directories are there.
Mm,
This temp directory. So this temporary directory and one is the user warehouse directory. So these two directory you create, and these two directories you give the,
permissions.
so once you give permission, so I think it is already created. Only thing is you have to give the permission. Okay.
Okay.
And once this done, now next is this is your change hivesite.xml.
Yes. Yes.
So go to your home
Software
and
is
do hive. Okay. So configuration. So it is not created. So this one is renamed to hivesite.xml. So
oh,
hive. So this all steps are there, and template you have to remove. So actually they're giving a template file, but we have to change it to hivesite.xml. And
okay.
once you have this hivesite.xml, okay, so we have to use this derby command to initialize the derby, initialize the schema. This is a meta store db. So our home path is already set. Just we run in the, anywhere we can run this command, and
Okay.
this will successfully done. So it means lot of step is missing, right? See, this is giving some, your hivesite.xml has some character issue. Okay, some character is saying 3215 line number. So you have to open this hivesite.xml. If you have seen my installation video, you can correct your error, right? One YouTube, there is a installation video is there, right? Where I have done this all things which I'm doing now. 3215 line number you go. There is some illegal character is there from the, see this one. So this character you have to remove, okay, and save this file. And again, after this, now again you run your schema command.
Okay.
Okay. So now you run a schema command. If this schema command now it's giving other different error. So your db is already created. So we have to rm minus rx.
Okay.
So underscore db. Okay. Now I do again this.
Okay.
If you already followed the proper steps, so this problem will not come because you initialize,
Yeah.
you jump to, so that's the reason it takes. That is, Yeah, it's okay. So yeah, so now your this Derby database is initialized. Okay,
Okay.
and now you will start. This is the last step. Okay. Now you will get still one more error. That will be IO temp dir. Okay, so these are all like predefined error, right? That will come. I already told you, right? Because
Yeah.
everybody will get this error. Without this error, you can't start your Hive. Okay. So go to same your Hive site.xml, find this property, and wherever this property is coming, remove this property. And very carefully, wherever the property start and where property end, delete all those. Okay. So it will be 5 times. So you have to find all those properties and delete. Control now. Find. There are the 2 places. So I'm removing property start and property end, then property start and property end. Okay. So all those 5 occurrence, right? I remove. Now I have removed, and I will save this file. Okay. Now my file finally my file is. So last time you were getting issue create database, you were not able to create a database, right? You were getting some
Yeah.
So this time when you do the create database, you are able to create it. So I'm telling you, if you follow the proper correct step in a one go, you will install Hive in 10 minutes. Okay. Okay, suppose I give my database is created. So databases. So you are so now you can run your commands, right? Now your Hive is ready. Okay. So you can work
Thank you.
on Hive.
Okay.
So follow the one installation video you can check in the YouTube. Okay, I already mentioned that one, right? Installation, there is a video is there, right? In the your classroom. If you have seen in the classroom, right, there is a video. Okay, check that video. If you are having a doubt to follow, okay, and there is a document also. So in this website, some steps are wrong. Okay, see website reference I given just for reference purpose. Okay, but just match with my steps and website steps, like something I have done change. Okay. Okay. So don't blindly follow the website. Okay. Got it? Okay. And
Sure.
if you
Sure.
have doubt, anything, follow the video. You can go to that particular video point you go where I'm installing Hive. Just it will take 10 minutes only because I have installed in video, just 10 minutes I installed. So it will take you 10 minutes to understand the entire process of installation Hive. So you will not get this difficulty you are getting. So everybody will not come to me, okay, I'm having this problem, I'm having this problem. Because you will be bringing the same issue, whatever I fix here. Because issues will come, right? If you don't follow proper way, your issues will be coming same. Okay. But if you follow proper way, I'm telling you, you don't need to come to me. You will say my Hive is installed in a one go. Okay. Yeah. And you can remove this one, right? This one. Okay.
Okay. Thank you.
Yeah, please install Hive. Okay, I'm telling you it's easy because I'm giving you way like you should install Hive and then come to me. Okay, then you install. Okay, because I will not install everybody's system, right? I want like you should learn how to install, right? If you have the steps, everything you have. Okay. Yeah. Okay. Thank you.